Good evening, all participants. The today's expert is about to join the session, so we will start after 5 minutes. Good evening, Dr. Neeraj sir. Are you there?
Madam, good evening. Am I audible?
Yes, sir. Yes.
Yes.
Shall we start, sir?
Yes, ma'am. Please give me
Oh,
2 minutes. I just be
yes, sir.
to
Okay.
start.
So, good evening, everyone. On behalf of organizing committee, I welcome you all to today's FDP session. Today we have with us Dr. Neeraj Kumar Varma sir. He is currently an associate professor in Department of Metallurgical Engineering at the OP Jindal University, Raigarh, Chhattisgarh. Previously, he served as an assistant professor at OPJIT from 2012 to 2022. Dr. Verma was a postdoctoral research fellow at the Material Science and Engineering AGOU University, South Korea, from March 25 to September 25, and worked as a researcher in the Department of Metallurgical Engineering, NIT Raipur, from 2019 to 2023, and worked as a project researcher in Material Science Division, CSIR, that is Central Scientific Instruments Organization, Chhattisgarh, from 2009 to 2010. Dr. Verma has authored 30 plus SCI peer reviewed scientific journal articles. He is also a lead inventor of 5 granted patents in British, Germany, Australia, South Korea, and South Africa. His research interests include alloy design, lightweight composite and aqueous corrosion, powder metallurgy, composite testing of material, and nanoscience. Now I request sir to continue the session. Thank you.
Thank you, Professor Susma. I'm really happy over here uh, for the nice introductions. So, so my screen is visible. I think so.
Yes, sir, it is visible.
Yeah. Good evening. As already discussed by Dr. Sushma ma'am, that my name is Dr. Varma, and as I'm currently working as a professor in the Department of Metallurgical Engineering at OP Jindal University, Raigarh. So my actually talk is related to the corrosion prevention and controls. So as you may aware that we live in the era of metals, and I would like to say that as per the data of your tables, more than 90 elements are come in the category of metals, which usually are very more reactive with respect to the environment. So the corrosions is basically concerned to the reactivity of the metals with its environments. So now the questions arise over here: why the corrosions is so important for us, not for academic, but also be main prominent requirements in the industries today. So I have actually, if as per the data, the corrosions basically are the more requirements for academics, industry, and research point of view based on the societal needs. The first, actually, why the corrosion is so important. The reason is that the first thing is that uh, uh, the human health and the safety. This is the first, actually, main the reason for understand the corrosions. Why humans life? As you understand that the corrosions is a big concern for everywhere. Most of the industries actually looking the metals which have the high strength, but they are a little bit bothers about the corrosion concerns. Reason is that I'm talking about one incident happened in the December 1984. This incident happened in the Bhopal. I hope so. Most of people know very well about the gas tragedy in Bhopal. More than 10,000 people was basically uh, injured and maybe the suffering from this type of disasters. Not only this, but if we look the other countries, the University of Virginia, one balcony basically was collapsed due to basically poor and propagating the corrosions in the concretes. So I'm just going to, this is the one going to discuss and elaborate one by one. And second point, which is very important thing, is that the corrosion, the cost of corrosions. And why cost of corrosions is one of them. The cost of corrosions is just, you can say that the Indian governments basically are now concerned about the protections of the metals. Metals have very reactive, not only the one area, but if you look about the manufacturing, the food industries and nuclear industry, and you can say that in the construction industries, automobile industries, so where the metals whose large quantity used, they usually reactive with respect to the environment. So I'm going to discuss such type of things which really help for the understandings about this corrosion. So these are my some contents. Why corrosion studies are important for metals, what is the general concept, and the real life examples of the corrosions and impact of corrosion on our society. And there are some fundamentals of the corrosions, type of the form of the corrosion and its control, and what the measures for control the corrosions under these segments we discussed in my discussion. So as I discussed that why the coral study is so important, the first point is the human life and safety. You can see that there are some several incidents which we have captured and get from various resources. In the year of 2018, the Italy, you can see in the left side that this bridge has been the collapse due to the improper maintenance and and corrosion concerns. More than 50 people has been actually the death that times. So the reason is that this bridge basically was constructed 60 years ago, and people are not more concerned about it. And if you see the case for the 1997, the balcony collapse at the University of Virginia, that you can see that also be the same, because the year, if you see that the corrosion is big concerns. Like this in India, the Bhopals, the December 3, 1984, this also be one case record, and that was happened due to the corrosions. This is the first actually point, very important point for study the corrosions and the concern of corrosions for the society. The second point, which is very important, the cost of corrosions for our society. What does mean that? uh, it means that if you can see these spectrums globally, like United States, India, Europe, Arabs, China, Russia, Japan, Asia. So the total cost of corrosion in USD, and you can see that the 28% basically covered under the Europe regions, and the 22% basically in Arab world. Reason is that they are directly concerned to the environment.
Excuse me, sir.
Excuse me. Yeah.
Sir, the slides are not changing.
Okay. Okay, ma'am. Now it is okay, ma'am.
No, sir. The first slide is only visible. The title slide is visible only. Yes, now it is changing.
Yeah, thank you, ma'am.
Okay.
Now it is okay, ma'am.
Yes, sir.
Yeah. So the second point, I'm talking about the impact of corrosions on society due to the cost of corrosions. If we look these spectrums throughout the universe, that the maximum countries like United States, India, Europe, Arabs, China, Russia, and Japan, the maximum dominance, the corrosions concerns is 28% recorded in the Europes, and 22% has been recorded in the Arab worlds. And if you look in terms of the cost, that the cost according to it, that the data which has been published recently in the year of 2015, uh, that has been estimated that 5% of the total Indian GDP has been used for protect the metals from the corrosions, and that estimation is nearest to 12 lakhs crore rupees per year. This is the Indian data which has been published in the various journals. But if you look the same things in the USA, that is the 6% of the total GDP. So the cost of corrosion can be calculated from the various uh, the domains. Yeah, the domains like you can say the transportations. You can think that the petrochemical industries, the construction industry. So if you look and just calculate, estimate this cost of corrosions is more responsible for any nations. So that you can see there are some several the life examples that like this is directly concerned toward the cost, because if we purchase a cars, and cars is basically over the 10 to 20 years that you can see the situation in the bottoms, and because the most of the parts going to rust. And the same thing for the engines components, and the components in the automobiles part, they got rusted from the atmospheres for constant with respect to times. So it has been the estimated the COC from various sectors like you can say the transportation sectors and utility sectors, infrastructures and manufacturers, process plants, and many more. So is it visible, ma'am? My PPT?
Yes, sir.
Yeah.
But the
Thank you.
slideshow is not on, sir.
Nobody okay, ma'am?
Sir, still the slideshow is not on, but the PPT is visible.
Ma'am, now it is okay?
Uh, no, sir. I think you select current window in presentation. You have to select full screen.
Okay, okay, ma'am. Thank you, ma'am. Just trying.
Ah. Yes, now it is okay, sir.
Thank you, ma'am. So I'm talking about the concept of corrosions and what does mean of corrosions and why corrosions came into the pictures. If you look the metals, basically metals um, uh, are basically come usually extracted from the ores and originally. And if you look these spectrums, you see the chemistry of the ores that they are nothing. It is oxides, and when we basically require some sophisticated process for get the extraction of the metal from their ores. First, initially, it goes from the blast furnace and SMS and the others, the fabrication process. So that's why we convert it into the the pure the irons. Irons basically we balance the carbon the chemistry and convert it into steels. And the steel it's help we generally use for particular applications, like if talking about the pipes, TMT rebars, and some others appliances. So when these metals basically uses in the same atmospheres and the same conditions, after several years, what happens? This basically the metals converted into its original positions. So the initially it was in ores, and when we extracted the metals, because whose amount of energy the requires manpower requires, and after that you use these components in for our daily life, and when they actually interact and come in contact with the atmospheres, it actually reached the in a form of oxides. So that means to say that this cycles is nothing that is the reverse of the metallurgy. And I will tell here over here that corrosion is nothing that it is a natural process. We cannot permanent control of the metals because it is natural behaviors. But if we understand the science behind this, we can control, we can extend their service life for some extent for several years. These are several areas you can say where the corrosions is big concerns, like you can say the pipe industries, the pipe corrosions like erosions is one of them. And the pipes is not just for using for the irrigations, but it also be using for transport of gas under the sea and many more areas. And another point is the structures. The structures basically the rail structure, airport structures, and ship many more. So another was is the bolt and nut corrosions. You can see that this is some dissimilar concept because some galvanic couplings and maximum metals basically corroded. So similar thing is that which has been discussed some several examples that was related to the reinforced structures, aircraft, the corrosion structures, rusty windows, industry corrosions, and you can say especially for the transmissions lines where the aluminum wires usually using. So people basically don't know about the basic things. So that's why the rust usually get. And sometimes what happens, the wires which is just go above from the cities, sometimes it is fall downs and maximums the things happen for the lives. So that is just a people's using the steel wires with over the aluminiums. So you can see this also be one area for the for corrosions. So basic the academic definitions, if you look about the corrosions, corrosion is nothing that is it is the detailed loss of materials and its critical properties due to chemical electrochemical attack chemical attacks. So we can understand these things is very simple examples. If you have a metals and you these metals basically you immersed in particular electrolytes, here I have using the hydrochloric acids. So this metal basically react together, and it is just after sometimes you can see some bubbles start to form in the vessels. And this basically is nothing that is the volatile some gas the produce. When the zinc I have used here, the zinc react to the hydrochloric acids, it is usually converted into the zinc chloride and the hydrogens. Hydrogens basically are you can say the gas which is come out from the reactions. So this is just the equation number represent the chemicals. We can understand this equation number 1 with the help of electrochemicals because electrons is involved. The zinc basically converted into zinc chlorides means to say that the zinc oxidize first, and here in the second the hydrochloric where the protonation H plus ions are there, they will be reduced in the reactions. So the two reactions, first is anodic and cathodic reactions, we can think here from the equation number 2. So this just a basic understanding of the corrosions, where the two things is that the oxidation and reduction in the same systems occurred with respect to the atmosphere. Yes, the environmental factors play a very significant role in the corrosion. We can say that because the corrosions component related to the environments and the metal systems is under specific conditions. What type of environments? If we are staying basically staying long period of times in the industrial environments, so these industrial environments have some sulfur dioxides. The sulfur dioxide usually come from the power plants, because the coals is main resources. And in the rurals, you can say such type of the waters, ammonia, and others atmospheres like chemicals, and you can say some gas along with some aqueous media are also be involved in under the environments. And metals, you can see that these metals using several areas, maybe the steel, stainless steel, aluminum, titanium, copper, nickel, and many more. But but both the things will come together under specific conditions like a concentration, temperature, fluid, stress, presence of oxygens, absence of oxygens, and some pressures. So these are some area, some we can say the factors which directly influence the corrosion. You can say there are some several studies that has been conducted, and it has been seen that if the humidity is high, so how the basically metal uh, get corroded. So so you can say that the high humidity is also be responsible for corrosions, and even the pressures as well as the temperature is equally responsible for propagating and the corrosions over the metal surface. And in the last, the pH values, basically pH is nothing that is, it decide the basic and the acidic and basicity of the systems. And if the systems go under the low sevens, it is acid, and you can see that corrosion rate usually affects with respect to the pH values, which directly related to the environments. The another point is that every metals basically have going to, sometimes they will be reacting with the atmospheres, but in other conditions sometimes the metals itself save their life. But how they save the life, they have some immunity in their systems. If the metal basically, like you can see the good examples of the irons irons, and this plot basically is with respect to the potential and the pH value. And in the bottom sides you can see that the metals, basically the irons, showing the immunity. And after, if the potential value usually increases and reaches up to the 1 volts, so and the pH value reaches the 3, thus basically the iron start to oxidize. So in a particular conditions, the sometimes the irons will be the high humidity, there is no reactivity in the atmospheres. But if the potential shift, a potential changes, the reactivity of metals increases. But in some cases, it also formed the oxides like Fe2O3 that also be stables. It will not be corrode too much. So the pore box diagram tell about the potential pH behaviors of any metals, not only irons but aluminiums and every metals we can see and check. This is directly related to the environments. So these are just examples of the corrosions of steels. This is the TMT rebars. You can see that the TMT rebars basically get exposed from the atmosphere. The atmospheres have the available of oxygens and some the waters, which basically that may be in terms of the most. So what will happen if in some point of contact over the TMT rebars, the metal usually oxidize. And you can see that this is just an area, the one area where the basically height of these rebars is slowly down. These metals really is activate or try to or is oxidize. And when during the oxidation, what happens, they obviously release the electron, and the electrons will be consumed somewhere in the same systems. And basically, as I told, that the waters and oxygens are there, these electrons will react together and form hydroxide. The Fe2 plus ions again react to the hydroxyl ions and form the ferric hydroxides. This ferric hydroxide is nothing that is a good, passive, you can say. This is the passive area, and metals will not reactive. But the rest of the parts where some points start, slowly it is going on, and automatically it is moving all till the eatings all the entire structures. So according to mixed potential theory, the net charge, either the oxidation and reductions, they will be accumulated in the same systems. So this is general examples which we can see everywhere in the construction site. So if we look very as per the electrochemically the propagating, the basically some holes are there. Here iron at anode sides. The iron usually the first is the anodic reactions that will actually propagate at anode side, and other reactions where the charge which basically coming from the anodes, it will consume at the cathodes and convert it into hydroxides. The totals you can see that hydroxides react to the available Fe and it converted into ferrous hydroxides. So the rest is nothing, that is oxides. Oxide that depends on the available supply of oxygen in the environments. So basically, as I talk about that the number of metals in the periodic tables available, so how we can say that the which metals is more reactive, which metal is the least reactive in these systems. So how we can actually measure of them. Some metals basically are very least reactive in the environments. Some metal is highly reactive in the environments with respect to the hydrogens. So the first point is that the potential. The first, every metal have their own potential, the standard potential value, and we usually calculate this potential with respect to the hydrogens electrodes. This is, you can say, the reference electrodes. This reference electrodes is connected with the metals. Here I use one example of the zinc. Zinc is connected to the SHE. So what happens? Some electropotential value, that is the minus 0.76 volt, which appear in the voltammeters. So parallelly, if we put and replace the metals, zinc with the irons and many more, we can get this potential. So on the basis of potential value, and potential is nothing that is concerned to energy. And you can see this diagrams basically responsible for and tell the more reactive and least reactive metals. The metals which basically highly negative with respect to the hydrogen, they are reactive in nature, and those metals have the positive potential with respect to hydrogens, which is in the bottom sides. If, you can say that the silvers basically have the potential value is plus 0.80, and the lithium potential value is minus 3.00 volt with respect to the hydrogens, because reference electrodes we will using for calculate this potential. So the lithium is more reactive, and the others basically where the positive potential they will be as a cathode. So some metals are basically reactive and less reactive with respect to hydrogen. We can see from this series. This series is well known, that is the EMF series, and where this series used when we usually coat the metals. When we're going to actually protect the metal from the atmosphere, so that we have to select the metals with their the voltage. But the concern is that this EM series will be responsible for only the pure metals, not for alloys. So as per the as per the corrosion concern, it has been observed that the many applications you can see here, that the copper pipes connect to the steel wires, bronze propeller in contact with the steel hull, and even our cells. And if because in metallurgy we usually uh, uh, get the macrostructures, the metallography is one of the subject in metallurgy. So when we polish and get the grains, that we can see these types of situations. And you can see that some dissimilars, yeah, two basically different metals are work together in the same atmospheres. They actually produce is in a galvanic cells. So galvanic cells are whose basically large amount using in various places. So we can divide into various category. First is the it can say dissimilar electrode cell, differential temperature cells, and the galvanic cells. So galvanic cells basically can be classified into various categories. Sometimes the actually electrolyte I'm talking here, that is atmospheres. Sometimes the atmosphere of both the metals are same. Sometimes the atmospheres might be changed. So here we have confined here the molarity, because that is the concentration of the environments. Now other is the basically the chemical compositions. Galvanic cells some producing due to some chemical change, composition changes. What happens during the welding process? We have seen that the metal basically the start to produce the new phases within these structures, and that times so that times so just such type of gas, the cells usually formed in the system. You can see some good examples from these pictures. This is the mild the steel nut, and this is the brass screw. The two dissimilar metal are work together, and how the mild steel is react highly with respect to the brass. So such type of basic situations you can see everywhere, and that is nothing's come under the category of galvanic cells. How we can understand this galvanic? Good examples is irons and copper is there. If we have the irons and you want to save the irons, so we can actually somebody, because the copper is cost, so if you just coat over the irons, so what will happens, the copper usually have good the high potential value in positive sides with respect to the irons. So obviously iron bulk work we have as anodes, and copper will be have as a cathodes. So overall, we can see and calculate the potential of the cells, and and on the behalf of that, with this dissimilar concept, we can check which metal is more noble and which metals is least noble with respect to the atmospheres. So what happens when both the metals or dissimilar metals are connected together? Here the zinc and copper are there. You can see the atomic scales. The zinc, what happens? Zinc and copper. Copper, obviously, as I told that this is the cathode in natures. Zinc is anodic in natures. The zinc start to oxidize and it produces some electrons. Electrons basically come from anode to cathodes. So here in the right hand figures, you can see the zinc and copper. Copper basically become more rich, and the zinc start to dissolve in the solution. So what is happen? It is naturally happen in every place where the engine component uses. It usually happen if they are present in the atmospheres. Sometimes what happens, it is very difficult to diagnose that which metal basically anodic and cathodic. So that times the situation is entirely different. So we have to calculate the potential value of both the metals, and that times the concentration of both the systems are entirely changed. You can say the dissimilar molarity of the same systems usually happen. So that time separately we have to find out the potential of X and Y with the help of this equation. This is the next equations which tell about the new potential value with the standard potential, and you can get it which metals will be have as anode and cathode in the system. These situations usually come into um, in the galvanic cells. So this is just the another examples. You can say that this is the macroscopic galvanic cell corrosions, and how the metal basically got rusted in the atmospheres, and how the rust basically is appear. You can see in these situations. So basically the product which usually formed, whether the ferric hydroxide, ferric trihydroxides, this is nothing that is depends on the supply of oxygens. If oxygens is very limited, the product, the basically corrosion product will be FeO and Fe3O4s. If the high supply of oxygen is available in the atmosphere, so the oxides basically will change, which is basically can seen from this single electrode system in the atmospheres. Another good examples you can see these galvanic cells in the stainless steels. In the stainless steels, what happens? You can see the basically the stainless steels basically have tendency, if it is basically operate at particular temperatures, that the temperature is known as the sensitive temperatures. This creates a new phases. This new phase is nothing that is a chromium carbide which is settled down at the grain boundary, and you can say this chromium carbide, it is one phase with respect to the matrix. These are two basically the different uh, different phase in the same system. It will be have as a some phase will be have as act as a anodes and cathodes. So some cells start to form within the systems. So that basically creates a new types of the corrosion that known as IGC, that we call this intergranular corrosions. So I will discuss these things later and how we can control them and the protections. This basically one cells. This is the galvanic series. You can say most of the people know very well about the galvanic cell, because EMF series have the limited scope about the metals. The metals should be in pure form, but if we're looking and using the alloys, so that where we now how can choose the nobles and least noble metals from them. So I think galvanic cells, galvanic series is only the way we can say the methods that we can see the highest anodic and cathodic metals from this series. Example is you can see the graphites and just compare of magnesium. Magnesium obviously is the last the highly reactive metals, and the graphites is very noble because the potential is very high. So we can see these things from the galvanics because it is directly concerned only the alloys. The temperature differential cell is one of them. Sometimes it has been seen that if the temperature of the same systems basically changes, that like basically you can see these pipes basically transport in the transmission line, some gas are passing through for one place to others, and when it is hot, gas is passes from one place to and propagating for long period of times. It is cool down. So there are two areas. The first is high temperature and very less temperature. So the anode and cathode region usually formed due to the temperature effects. So number of good examples we can see over here. And the another one, the study basically conducted by in the year of 2012 with the using of copper metals. Basically, these metals using as a heat exchangers materials, and in this case, they have using one electrolytes that lithium bromide solutions, and they vary the concentration 400, 700, and also the temperature vary from room temperature. It is reaches 100-degree temperatures. And after that, he actually conducts some experiment. This is the polarization curve over here on the left hand side. So you can see that uh, uh, you can see the results. What happens when the temperature increases? Obviously, your corrosion rate is increases. Is if I core is increases means to say that the metal is becomes the will behave as a anodic, means the corrosion rate will high. So in this trend, we can see in every situations, the on increasing the temperatures, the metal usually behave as a anodic, and it will be activated in the particular systems. Another point is the passivations. Basically, passivation, somebody know very well. This is actually using for because we using for some coating materials. Coating materials generally made by metals and polymers, and some ceramics we can coat over there. So the metals, the aim is we have to protect them. But how the passivations will happen in the systems? We can see this polarizations curve with the polarization curve. You can see that these polarizations curve tell about at the fixed potential value, the at particular potentials, the metal usually reactive to much high rate, and after that, when the potential basically uh, um, at fixed I core, the potential become stagnant, right? So these situations you can see that times their I core, yeah, the corrosion's current basically will not be responsible. They will be um, stagnant in these regions, means to say that the metals basically become passivate. So passivations can is nothing that is some formation of oxides, and if you supply the high amount of potential from the systems, it again start to propagate. So that the reasons will known as the trans-passive reasons, right? So we can because we calculated these things with the help of peeling width ratio. It is nothing that is volume of oxide produced by the systems by the volume of the metal consumed by the systems. So this PV ratio is responsible for the protectives and non-protective, means to say the passivate and not passivate. So we can see that these some several examples over here. That's a good example of aluminiums. Aluminiums basically have the passivity is nearest to 1. So this basically is good and adherents the passivations. We can calculate it every metals with respect to the atmospheres. So now the thing is that how we can classify the corrosions. The corrosions are different category. and some of the uniform corrosion, pitting corrosion, intergranular corrosions, and some are, or you can say, just galvanic corrosions, which I already discussed. So now I am going to discuss one by one. This is the uniform corrosions because the entire surface are rusted, rust, get rust in the presence of the atmospheres. So this metals basically uniformly entire surface exposed to the environment. This is a uniform. So the uniform corrosions can be classified and measured with the help of the corrosion rate. If any system and component have the corrosion rate 0.15 mm per year, so that you can say that is a good corrosion. If the metal basically lie the corrosion rate between 1.5 to 1.5 millimeter per year, that is a satisfactory. If the metal have the corrosion rate is more than 1.5 mm per year, it means to see can say that this is the unsatisfactory, not satisfactory, and because it is a serious case, and we have to take some measures for such metals. So the calculation, the corrosion rate is basically we can calculate with the help of some test. I will be showing you in the later. And this the rate basically with respect to the applications is you using the valve pumps and shaft impellers. So what should be the corrosion rate in these situations that we like, so you can see in case under the uniform corrosions. Another corrosion is the pitting corrosions. Pitting is also very big concerns, and you can see the pitting basically is just a small holes in the structures. It's when you see the naked eye some points you can see over the surface, and these holes basically creates and basically eatings all these structures, and it has been estimated that this pitting corrosions is more than hundreds times higher than just than the uniform corrosions. And what is the reasons? Basically pittings uh, usually basically happen due to some metallic and not metallic inclusions in the steels, and you can see several examples of the pittings. Some metal basically when the pit start at the fixed point, that it is propagating, and after sometimes the the whole structures usually get corroded. So this just you can say the mechanism, the small holes basically will form in the structures, and when the metals basically start to oxidize, so in the presence of the oxygens and the waters, so what happens, byproduct the hydrochloric acids formed. You can see the equation, the hydrochloric acids formed in the systems. This is nothing that is the acid. So you can say when if the pitting start in the presence of atmosphere, it is categorically, and there is no force required for other sides. It is propagating and moving if you have not taken some measures. This is just the shapes of the pits. It is just you can say how it is the propagating inside the structures, but it is usually moving towards to the gravity. On the basis of chemical compositions, we also calculate the PRN number on the basis of chromium, moly, and nitrogens of the stainless steels that we call this PRN number. And such examples you can see in the right hand sides. So on the basis of the chemical compositions, we can see the highly resistant metals that based on the chromiums and the moly and nitrogens. So which I already discussed these things. So what happens when the metals basically start to react at the particular spin point? The rest of the parts you can see that is a ferrous hydroxides. This is nothing saturant layers which is deposited over the surface. It is a corrosion product you can say, but here there is no reactions will be going on, but rest of the parts where the pH reaches 2 to 6 that times basically reactions and some metals will highly rusted How we can control these things? But we have to control the pH value. We can use some good inhibitors. Cathodic protections is one of them, and some coatings also be one remedies for control the corrosions. Another point is that if we are capable enough to stir these electrolytes, because stagnant of particular solution the atmosphere is one of them, we have to stir them for disturb. So such type of good examples, and the incident happened in the year by year, which is due to the pitting corrosions in the structures. Another is intergranular corrosions. You can see that the metal, basically some metals, they say, just like get exposed to the temperature, and they start to form the new phase within the grains boundaries. And here you can see the chromium depletion regions in the grain boundaries, which is more reactive with respect to others. And so what happens? The depositions of forms the phases within the grains responsive for the IGC, which is usually happened in the SS metals. Now, how we can actually control them? The maximum options is we have to actually control the carbons. Carbon controls. So what will happen? The peoples replace the carbons. Basically, it convert into 304L. So low carbon, if we using that, it is the activity of chromiums will be less. So we have to use the another elements which is good. The carbide formers like a titanium, niobium, we can use and control the IGC. Some post heat treatment is also good, because solution heat treatments of the wells, because they have the enough chance to dissolve into these structures for control the IGC. These are some case study, just the related of the IGC in the turbine blades, which is due to the carbide formations. This precipitate usually happen at fixed temperature and are related to the IGC, and whole components usually failed. The another testings you can say, now just I just previously discussed about the corrosion rate, how corrosion rate we can calculate it. The corrosion rate can be calculated with the several way. First is the weight loss methods maximum people's using, and this is just a traditional method. But new techniques, basically, as we have electrochemicals techniques are there. On the basis of LPR, linear polarization resistance, we can this basically also be useful for calculate the corrosion rate as well as RP, the polarization resistance of the samples. If this general formula, the CR is I core W upon AD, W is the weight and A is the area, and D is the density of the metals. But in combination electrochemical systems, we require three electrodes: the counter electrodes, working electrodes, and the reference electrodes. These three electrodes work together in the same systems, and we supply. If we talk about this is a potential state, we need to provide the potential, and we have to check the response of the currents. We can see these things from the polarizations curve. If the basically if we talk about LPR, this is linear polarizations, because very less amount of potential required, and if the potential is high, that it's go the potential dynamics polarization curve. So that related to steady to steady. So basically, this is the corrosion kinetics, and I'm not going discuss very broadly about it, because if we supply under the potential state, if we supply the potential and we want to check the response of the current, that some equation has been established by from the Butler-Volmer, and this you can see this I core is directly related to the potential value. So you have here you can see that two reactions are there. The first is the anodic reactions, and another is the cathodic reactions. And oxidation and reductions usually happen in the system, and that can this is the basically case for the Tafel equation, how the oxidations happen. If the potential is basically high, and if you see that that we can get it the relation between potential I cores, and we can understand these things with the help of Tafel equations. So I hope so most of the people might know about it, because it is usually required in case for the linear polarizations, where we want to calculate the corrosion rate of any samples by LPR. So now the question is that if you have the environments and you already checked and calculate the corrosion rate in the various units, because it is maybe converse into per year, miles per year, and maybe more than that. So here basically you can see that the servals metal are there, aluminiums, irons, and lead. So you, on the basis of corrosion rate, you can see that which metal is the outstanding, excellent, good, fair, poor, and acceptable. It obviously that if corrosion rate is high, that is in case the unacceptables. So that we have to think um, for good solutions, and increase the service life of the component in the atmosphere. So these are some several basically corrosion control methods. First is the material selections, how we can control, because I already discussed several examples, the form of the corrosions in the systems. But now the question is that how we can control. So we have several techniques for mitigation of the corrosion systems. The first is material selections. If you well known about the environments, so that times you have to check and properly use the metals. Okay, which metal is the least reactive in the atmospheres? That based on it may be the manufacturing process, it may be the cost, and the appropriate the corrosion rate in the systems. So another point is the cathodic protections. The cathodic protection is widely used in the industry today, and peoples are actually control the corrosions of pipelines and very large structures which inside the sea as well as in the soils. And thousands of kilometers is using for the gas and other things. Another is the anodic protections, because I already discussed about some passivations. So you have to actually passivate the metals, but it is actually using under the low potentials. Another is the coatings. Coating also we one alternates the coatings, the organic coatings and metallic coatings generally basically using for protect the metal from the atmospheres. Another is basically inhibitors, and inhibitor is nothing. They also be control the corrosion rate into two-way. First is you can control anodes and cathodes with the help of the appropriate inhibitor in the solutions. Here we can say in the environments. So these are some combinations. You can say you have to smartly use the metal with respect to their environments. So you can actually save and extend their service life for from the from the environments, corrosive environments. The coatings, as I will discuss that the nowadays people using the galvanizing steels, and these are some sort of examples. The zinc coat usually happen on the steels. So how basically what the role of zinc of these steels? So the role of zinc, you can say that because here the two similars, as I already discussed in the galvanic cells, two dissimilar metal are work together. First is in form of the coatings over these steels. The zinc basically work as a sacrificial anodes in the systems. Zinc first start to degrades in the atmospheres. Reason is that the potential value of the zinc is minus 0.76, and in with compared to the irons, iron is minus 0.44. So obviously it is highly reactive to the systems, and first it is sacrifice and save the life of the steels. After that you can using, and many times you can use and save these structures. Another is the polymeric coatings also be using today. I'm talking about such type of the polyanilines. This is also we one alternates people are using and on the deposit on the surface, and they make the metals passive. Another is you can say the some basically the high temperature talking that the boron carbide and ceramics coatings will also be using for protect the metal from the corrosive environments. Now another point which is largely used, the cathodic protections. You can see one good example. The cathodic protection can be classified to two types. First is you can say the sacrificial anode we use, and another point is ICP. Impressed current we have to give into systems, and then we can protect the metal surface. In case of sacrificial anodes, you can see the good example in the right hand sides. If some basically the pipelines are inside the soil, so we suggest just far away we connect one appropriate anodes. Here we are using the anodes of the magnesium. Magnesium usually is more reactive with respect to the iron, which connected to the wires. So after some times, what happens? The magnesium start to oxidize. Oxidize means to say that it reactive much than irons. And you can say the environment have some amount of the oxygens and water may there. The electrons usually come from the anodes, from the magnesiums, and it react to the available, and that times your iron structures becomes passive. So in this way, people are using and protect the components with the help of some sacrificial anodes in the systems. So it also be one way. Another way is to that yes is to that is that impressed current cathodic. You can replace if you have not such type of things that we can using some rectifiers. The rectifiers usually provides some the charge to the bars, and obviously the steel bars basically converted into become a passivate, and this basically using for long period of times, and after that we can save the steel structure from the environment. Yes, another point is the inhibitors. Inhibitors can be classified because the main purpose of inhibitor is to say that they can uh, control the two. First is the anodes. It can control the anodic reactions, and another is second is it can control the cathodic cathode. Both directions can be controlled by using these inhibitors. In case of anodic, some chromates, phosphate, and such type of basically inhibitors can control the rate of anodic. And basically, when it reactive, the metals usually form the protective fields barriers, and it can control for further oxidation in the systems. And the similar things is using for cathodics. So we have to use appropriate inhibitors for control the corrosion rate in two-way. Another point is that a recent study was actually conducted in the year of 2023, and when published by Mohammed, he using the green tea. Green tea basically is a good. He using the two things. First is the tulsi and the green tea. This both basically surprisingly actually convert into powders, and after that he extract with the help of sodium hydroxide solutions. He prepared even electrolytes, and they have checked their efficiency in the with respect to the metals. And after that, they conduct the three experiment. First is without the without the mixture of tulsi and green tea, and another is they actually conduct in case of tulsi extract and green tea separately. And there you can see they using the two techniques. First is the weight loss methods, second is the polarization analysis. So in case of weight loss methods, first we have to calculate the weight is directly related to the first what we'll do, we take initial weight of the samples, and we can put the sample for long period time in the CA systems, and after that we pick the samples and we calculate the again weight loss W1 minus W2. We put in the above sides and we divided the area, time, and the density, and on the basis of that we can calculate WR. So here he has found that without inhibitors, this is the red colors, which is the weight loss is high, and with the tulsi, the weight loss is declined. They also we calculate the reductions. The reductions basically the 80% has been basically corrosion reduced with the use of tulsi with compared to the green tea. So now another is the same experiment we conducted under the polarization potential states. So they have checked that the I core basically are decreasing in case of the green tea and the tulsi. So that's why they have seen that this basically can be used as a good inhibitors and protect the samples with the available resources in natures. Another studies basically conducted not only these things, but people's basically what are the drugs used. They can also be basically can decline the corrosion rate in these systems. And one examples that this is the antinals one drugs are there. These drugs basically they have prepared the solutions and they have inserted into in the hydrochloric acids from the different ppms, and you can see that it is start from the 50 and go up to 300. So when the concentration increases of this drug in the system, it has been found that I course basically is decreases for the higher concentration up to the 300 ppms. The I course was recorded 0.1071, means to say that corrosion rate becomes very less with respect to the bare metal in the hydrochloric acid. So these are such examples that if we used the appropriate quantity of the inhibitors in the systems, that can decline and decrease the corrosion from the atmospheres. So I hope so. This is our facility in campus. This is just potential state, and we conduct some experiment in this area. So thank you very much, and I would like to special thanks from ma'am. Ma'am,
Yes.
am I audible?
Yes, sir. Yes.
Yeah.
Thank you very much, sir. Uh, any questions from participants? Participants, you can ask your questions.
Hello, sir.
Yes, sir.
Thank you very much for your very informative lectures. And I have a actually question that is that in one slide you mentioned that organic coatings for the corrosion control.
Yes.
That organic coatings, what type of organic coatings, generally chemicals are used there? I think you mentioned that polyaniline, I think.
Yes. Basically, the
Polymer, I think.
polyaniline is just a, you can say, um, uh, a polymers that can be synthesis by the sol gel methods, and people's basically conduct and reported these things. If polyanilines basically deposits over the structures, and if it is good adherent, and that it has been seen that it basically prevent the corrosion some extent.
But is there any other organic polymers are there that
Yes,
you?
yes. Polyaniline है, polypyrrole and polyethylene, polyacetylene. There are several categories in this range. But the polyaniline, because I have seen some reference, and so I have reported over here. But rest of the can be used as a corrosion as a coatings over the substrate. It is going on.
Okay, sir. Thank you.
Thank you.
Hello, sir.
Yes, sir.
Sir, thank you very much for this excellent session. I have one question, sir. Sir, can you measure the intensity of corrosion?
Intensity of corrosion means to say that efficiency of corrosions you can see in terms of the basically inhibitors, not intensity. Intensity you can basically we can confine it into several way, but this terminology which we have been using that cannot be correlated. But I will say here over here the corrosion rate I think is main of them. Yeah, corrosion resistance we can see that can using depth of penetration we can actually find out how much corrosions basically are penetrating to the structures. We easily calculated from the potential states.
Actually, sir, many times in terms of coating, we applied primer and followed by top coat.
Okay.
And sometime intermediate coat also. So this 3-layer coating take place. So this it is depend upon that intensity or any other factor.
Yes. In industry, basically, that you can use the zinc coat and the titanium, basically in intermediates coat. I have seen that, but they have the different the testing. Some they test the bond test they generally using. They actually the normal test is available for normal practice. But if we want to check very in the details, that we have to go through and see the under the scanning electron microscope how the metal basically the quartz is strongly bonded. Either is adherent to the surface. So that other sophisticated process we require to check the corrosions over the surface. So I hope so. It really help. Scanning electron microscope is one of the techniques that really help for the high magnification. We can check the three layers from the bayers, middens, and the upper.
Okay, sir. Thank you, sir. Thank you very much.
Yes, any other question? Participants, any query? One participant raised her hand, Uma Devi. Yes, any question?
Sir, I have another question. That you mentioned that inhibitors, inhibitors. I think you give an example recently, that is in the tulsi extract, and another was what was that? I forgot. And in that case, how they act as a inhibitor, how they actually do the work as an inhibitor or to protect the corrosion. As an inhibitor, how they protect the corrosion.
Yes. You have the nicely questions. Nice questions. This reason is that first I already discussed that first you have to check the normal. Just they have reported that they first initially take the weight loss methods. The first the bare methods you can choose, and after that whatever the inhibitors you using in the solutions, that against you have compare the corrosion rate from the bare solutions. This is the first way that you can see the difference. The another point is that you can check if you want to check that whether it is the anodic inhibitors and cathodic inhibitors, that you have to gone through for the polarization test. They can actually smartly tell about the anodes and cathodics behaviors on the basis of the top TEFL slopes we call, or that is a beta A and beta C. So on the basis of that, you can check the behavior of each inhibitors with respect to them. Usually, there's nothing inhibitors. There's nothing. They just absorb the surface. They kills the oxygens, and because you have to make the metal passivate in both the sides. So such type of things you can check with the help of both the techniques. The weight loss methods is generalized methods, and if you precisely check the behavior of anode and cathodes in both the sides, you can see from these potential states. It is well-known techniques available, I think, in most of the labs.
Okay, sir. Thank you. Thank you.
Any other question? Sir, from participants, there is a request to share your PPT. So you please mail me, this presentation to me so that I can share it to all the participants.
100%, ma'am. I will share with you all this. This is my content, and I request from the management, and especially you, that you share my mail ID if you have any doubt in futures, because
Okay.
related to the corrosions, I can actually nicely reports and reply your mails through WhatsApp and anything. So the finally is that I would like to give my heartful thanks to Madam. He constantly basically contact for this wonderful the event, And I also be basically thanks to management, the entire management of Vidyapith University. He gave me the good opportunity to share my thoughts through this platform. And the point I especially the emotionally tributes to my one close friend. His name is Dr. Gansham Burman, and
Yes.
because he was serving as head in the chemical departments earlier, and whom I can talk something well through this wonderful workshop. I really thank you so much, all of you, and for your kind support and opportunity. So thank you very much, madam. Thank you. Jai Hind.
Yes, sir. Uh, okay, so the session is concluded here. On the behalf of organizing committee, I extend my sincere gratitude to our esteemed speaker, Dr. Neeraj Kumar Varma sir, for sharing his valuable insight on the topic of corrosion, its prevention and control. Dr. Verma clearly explained the general concept of corrosion with relevant real life examples, making the session both engaging and easy to understand. He elaborated on the different types of corrosion, helping participants gain clarity on various corrosion mechanisms encountered in practice. Additionally, Dr. Verma provided valuable insight into electrochemical measurements used to analyze and monitor corrosion behavior. The session was further enriched by his explanation on various methods of corrosion control, including the importance and applications of green corrosion inhibitors, emphasizing environmental friendly and sustainable approaches to corrosion prevention. We sincerely thank Dr. Neeraj Kumar Verma sir for his time, expertise, and engaging presentation. The session was highly informative and enriching, and the knowledge shared with will greatly benefit all the participants in their academic and professional pursuit. Once again, we express our heartfelt thanks to Dr. Neeraj Kumar Verma sir for making this session a great success. Thank you very much, sir.
Thank you, ma'am. Thank you so much.
Participants, our next session will start at 7:30 p.m. Uh, because the expert will join till 7:30. So I request all to wait until the expert is joined. Participants, our next session will start at 7:45 p.m. So you can take break until 7:45, and I request all to rejoin again or be in the meeting till 7:45. Thank you. Welcome back all. We have our expert with us, Dr. Chintan Pandya sir.
Thank you, ma'am. Thank you once again.
Sorry sir, there is interruption. So it is again a pleasure to welcome back Dr. Chintan Pandya sir, who is Quality Control and Quality Assurance Leader on the fourth day of our Atal Faculty Development Program. Yesterday's session on quality control and assurance was highly informative and well appreciated by the participants. Today, Dr. Chintan Pandya sir will continue with further insight on analytical method development and data validation, helping us strengthen our understanding and academic perspective. We are thankful for his continued association with this FTP. Now, I request sir to kindly proceed with today's session. Thank you.
Thank you so much, ma'am. Again, I'm thankful to you as well as to the university officials, those who have given me such a wonderful opportunity to present myself as a speaker over here. And thank you all the participants who have means like patiently yesterday they have listened me with full patience, cool and calm, and they have keen interested in the topic discussed over there. Today I hope the same, and as ma'am discussed, today I'm presenting my topic, that analytical method, the development and the data validation. So ma'am, can we start today's topic?
Yes, sir. Yes.
So, as we discussed, that today's topic is related to analytical method development and the validation. So, first of all, if anybody knows that what is the means like what is the need of any method development, if anybody can give me the answer. If anybody knows, then they can give me answer that what are the needs of analytical method development.
Sir,
Okay.
analytical method development is very much needed to validate the data and the outcome associated with the expectations and predictions so that we can confirmly say that this data is validated by using this method which has been developed using the prerequisites. That's it.
Yeah. Thank you, sir. And as sir said, it is the rightly as sir said that analytical method development is needed, that to reduce the cost of chemicals, to reduce the cost of the time, because in industry time is more than the money. So to reduce or to save the time, money and chemicals, and to ensure the safety, efficacy and the quality of products, the method development are being used. And then we will come to the validation part also. As sir rightly said, the short meaning of validation is the method which can be used by one person, and the outcome of that method should meet with the another person or another lab also, but that we'll discuss later on. First we'll start with the method development part. Generally, method development is used for each and every method which are being means like to be performed to analyze any sample, or to analyze any product, or to analyze any pharmaceuticals formulations. Like in one pharmaceutical formulation there are plenty of analysis that we need to perform, means like starting from the description, then solubility, then identification, then assay by sometimes UV spectrophotometer, sometimes UV by dissolution, sometimes it should be assay by dissolution, sometimes the assay by HPLC, or sometimes assay by GC. So certain methods are there to analyze one pharmaceutical product. There are 10 to 12 or sometimes 15 analysis that we need to perform before releasing the product. To decide the quality of the product, this much test generally we are performing, and development should turn for each and every analysis method, means like starting from the solubility, then the identification test, then the assay test if it is there, then assay by titrimetry might be there, then assay by HPLC in some products, the assay by UV, or sometimes it is assay by dissolution also. So likewise, or related substance, or we can say the purity of the compound. Sometimes purities can be decided by the gas chromatographic method, sometimes the purity can be decided by the HPLC, high pressure liquid chromatography method. So certain methods are there to analyze one pharmaceutical formulation, and we have to develop the method of each and every analysis, like for high pressure liquid chromatography, for gas chromatography, for FTIR, Fourier transform infrared, then UV spectrophotometer, then the solubility is there, then the LOD, loss of drying is there, then the water by Carl Fisher is there. So we have to develop each and every method. The first step, we have to develop the method. as I rightly said that the development is expected to reduce the cost, time, and to ensure the safety, efficacy, and quality of the product. So, with this, the analytical method development are being initialized. So, which method in starting phase of the analytical method development, which method we have to develop first, we have to decide that. It's like which instrument we are taking for the development, or whether it is classical or instrument based. Classical means the manual titration is there, loss of drying is there, which is having only the use of the oven, vacuum oven, or whether it is the ROI, sulfated ash, which can be measured through the muffled furnace only. So likewise, this type of method we are going to develop, or the instrumental method where the use of sophisticated instrument like HPLC, GC, IR, UV, LCMS, NMR are being used. So these are the two categories of analytical method development. One is the classical and the second one is the instrumental method. So the development first purpose is to optimize the analytical method in such level that the use of chemical are being reduced and the time can be saved. Means like in shorter time we will get the efficient result to decide the quality of the product. Means like if the analytical method is having 60 minutes, so we have to optimize it, and our first our first purpose should be like how to reduce the time from 60 minutes to 50 minutes or 40 minutes or 30 minutes. So in shorter time we can complete the analysis, but the quality parameter should be same. It is not like that instead of 60 minutes, if we are reducing the time to 30 minutes, the quality of the product is being reduced. Means like we are not getting the complete data of the product. So we need to analyze the complete means like complete data of the product, but in a shortened time. These are the main purpose of development or the optimization of the current method. Accurate measurement, this is the first purpose, and the reliable results under the definite conditions. So there are certain techniques are there, likewise HPLC, then UV, GC, LCMS, and certain tests that we need to perform at the development stage. These are the parameters we need to measure during the development: accuracy, precision, sensitivity, specificity. And our purpose should be to reduce the time and the cost. This should be our prime focus, to reduce the time and to reduce the cost of the analysis, because these are the two parameters which can increase the cost of the analysis, and development are being just initiate to reduce the time as well as to reduce the cost. And that's why the complete cost of analysis will be decreased and the company will get the benefit in terms of the cost of the product. But while developing any method, we need to follow the QBD model. QBD model means quality by design. Quality by design is a sophisticated way of development a method. Means it is not like that if we are working on accuracy, so what should be our purpose? That the accurate result means like by the current method, if we are getting the result nearby 99%, so if we are developing a new method, result should be more than 99%. Means like 99.1, 2 or 3. It is not like that we are getting the result 98 or 97 or 95 in newly developed method. So there will be count as a meaningless method, because in older method or in current method we are already getting the purity 99%. So if we are developing a new method, it should be more than 99%, more than the current method. If it is less than the current method, then it will be a meaningless method. So we have to focus on quality by design. Means like we have to design a method in such a way that quality should not be bargained. So likewise, the accuracy means what are the expected results are being asked or are to be performed that should be meet with the specification. Means if we are targeting that we are claiming that we have manufactured paracetamol. So paracetamol is a name of a formulation, and the API being used in manufacturing of paracetamol, that is para-hydroxyacetanilide. So in QC analysis, we have to focus on para-hydroxyacetanilide. And if para-hydroxyacetanilide is being identified with the method, and if the para-hydroxyacetanilide are accurately measured, then the method, newly method developed or the optimized method is being meaningful. The next part, that is precision. Precision means what? If we are not getting the result accurate, means our expectation to get the result between 98 to 100. Okay, if we are getting the result in between 98 to 100, it will be known as accurate result, because what was our limit, we are getting the result in between the limit, so it is known as accurate result. But the precision means we did the analysis in triplicate. Triplicate means three times repetition of the same analytical method. If the method is of uh, purity by HPLC or purity by GC or assay by UV or the dissolution method, it is irrespective with the instrument being used. But accurate means if the limit is in between 98 to 100, so we should get the result in between 98 to 100. Then it will be known as accurate result. But the precise result means if we are repeating the same method for 3 times or 6 times, the every time the result what we get, it should be nearby each other. Means the standard deviation in between the repeated result should not be more than 2%. Relative standard deviation should not be more than 2%. It means the repetition of 3 times or the repetition of 6 times of the same sample are giving you the same result, or in the variation of only 2%, then it will be known as the precise method. Accurate method means you will get the first result might be 98, the second result 98.5, the third result 99, the fourth one that will be 99.5, and the fifth one maybe it is 100. But the all five results are being accurate. Why? Because the limit was 98 to 100. But precise result means what? That if you will get the first result 99.1, then in between the 2% of variation all results should fall. So if we will count the 2% of that relative standard deviation of 99.1, so all five results should fall in between 99.1 to 99.5 only, not more than that. If you will get the first result 98 and the last result 100, then the percentage RSD will be more than the 2%, and the result will be calculated as accurate result but not the precise result. Means your deviation in between the results are more than the expected. Though the result are accurate, but it is not precise. Then comes the third one, that is sensitivity. Sensitivity means what? That the lowest form of impurity should identified very well and separated very well. Means the highest percent will definitely separated. If you will take the example of any HPLC method, Then in HPLC method, which is having the highest amount or the quantification will definitely show a sharpened peak. But which is having the lowest amount, the impurity, which is having only 0.1% amount out of 100%, so might be the 0.1% get suppressed in between the 99.9% of other amount or other analytes. So the sensitivity says that each and every analyte should well separated from each other and should be quantified. If the amount is 0.1% or if the amount is 10% or if the amount is 50% or if the amount is 99%. But all analytes should get well separated as well as they all should get quantified. Means we should identify each and every one. That is known as sensitivity of the method. Now comes the specificity. Specificity means what? That analyte should get separated with the impurities and with the byproducts also. Means your method should strengthen enough that the analyte or the main API should be identified with the presence of all impurities or all the byproducts. Means the method should not be like that it can only target the main compound, but the impurities are not being identified or the impurities are being suppressed. Means we can only identify the main product, but the impurities are not identified. Though the impurities are there in the product, but your method is not capable to identify the impurities, it is only capable to identify the main product, then the method is meaningless, because we need to identify the main product as well as the impurities which are being present in the product or along with the product. So our method, we have to develop a method enough strengthened to identify the analyte as well as the impurity at the same time. And we should get the quantification, means like detection as well as the quantification of each and every analyte present in the product. Means like the main product and the impurities are present along with the main product, if it is byproduct or if it is impurities. So our method should be strengthened enough. Means like we have to develop a method in such a way. Now the steps which are being followed to develop a method, these are understanding the analyte properties. Means like your product, means like solubility of the product, because if we are developing a method, first we have to prepare a sample solution. But before preparing a sample solution, we must know that in which solvent are sample being soluble. So first we have to identify the solubility, then comes whether the product is acid, means like having the acid property or the base property, means the pH of the analyte, whether it is acidic, whether it is basic, or whether it is neutral. Then comes that whether it is light sensitive or whether it is temperature sensitive. So we have to identify the overall characteristic of the analyte. So before developing a method, we should get a clear idea of our all chemical and physical properties of the analyte. Then and then only we can jump to develop a method. Because before knowing the chemical or physical property of our analyte, we should not prepare even a solution of the same analyte. So we have to identify the chemical and physical property of the analyte first before developing a method. Then comes to the analytical technique, that which technique will be suitable to analyze or to identify our main product. Means if it is volatile, then we can go for the gas chromatography. If the compound is not volatile, then we can go for the HPLC method, high pressure liquid chromatography method. So Before that, we should know the characteristic of the analyte. Then we can choose the analytical technique accordingly. Then comes with the solvent or mobile phase. Means like which mobile phase, if we are taking the example of high pressure liquid chromatography, then which solvent should be used. So according to the solubility of the analyte and the pH of the analyte, we can choose the buffer solution. Means likewise, the analyte, if the pH is pH of the product is 6, then we should select the buffer nearby 6 pH as a mobile phase. So what will be our benefit by preparing the mobile phase pH nearby the analyte pH? Because at the same pH, the analyte being separated instantly instead of the different pH. Means if we will match the pH of our mobile phase with the analyte pH, and if both pH are similar to each other, the mobile phase pH as well as the analyte pH, then it will not take much more time to elute. The separation process is being faster, and if we will not match the pH of the mobile phase with the analyte pH, then it will take much more time to elute or to separate. So this is an important step in the development. Now comes the optimization of the different parameters. So which step we can means like after completion of this step, the optimization means uh, the organic or the we can say the organic solvent, means like the polarity of the solvent. The elution can get more faster if the analyte is polar, and we will choose the mobile phase polar. Means the polarity of mobile phase, if we will increase, then the possibility of analyte elution is being higher. So this comes in the optimization step. Means like the polarity of mobile phase can change, pH of the mobile phase can be changed, temperature of the instrument we can increase or decrease according to the temperature range of our targeted analyte molecule. Also we can change the flow rate. Flow rate, if we will change faster flow rate, will get a chance that the elution of the analyte will comes faster. And if we will give it a slower flow rate, then there are chances that the analyte being separated later. So these are the optimization step which can be used afterwards. Likewise, as I said, 4 or 5 steps that we can optimize: polarity of the mobile phase, temperature of the instrument, flow rate of the mobile phase, as well as the pH of the mobile phase. These 4 or 5 steps we can optimize increasing or in a decreasing manner to reduce the overall analysis time. Then comes with the system suitability. Means we have to identify the analyte with the impurity. So as a standard, we need to we have to inject a system suitability solution which should have the main compound as well as the impurities. So it is known as a mixed standard. And in mixed standard, the main product should be present along with the all possible impurities of the same compound. And if the mixed standard injection will give you a well separated chromatogram, then it is known as that your system is working perfectly. Because before doing the commercial or routine analysis, we have to identify that our system is working perfectly, and To identify whether our system is working perfectly or not, we have to inject a system suitability injection. In system suitability, the standard as well as the possible impurities are being present. If they all will get identified or well separated, then it is known as our system is working perfectly. And then comes the documentation part. After following each and every step, we can finally document the analytical developed method. So these are the steps are being used in the development of any method to identify the physical chemical property according to the selection of method. Then comes with the solvent or mobile phase being used, and then comes the optimization step where we can change the temperature, pressure, the pH, flow rate, etc. to decrease the runtime of our method or to decrease the time of our method, which was our primary focus. Then comes the system suitability, means analyte should identified and quantified with all possible impurities at the same time. If that particular sample is working perfectly, means the system is working perfectly. And then comes the documentation part. So these are the steps we are following in development of method. Now comes the factor affecting the method development. Chemical nature of the analyte means if the chemical nature of the analyte is suppose basic, highly basic, means the pH of the analyte is 11, 12 or sometimes 13. So it is known as highly basic analyte. So if it is highly basic analyte or sometimes it is highly acidic in a nature, means like the pH of the analyte will be 0.5, 1, 1.5 like that, the highly acidic. In such condition, a development will get affect. Means like we are having only we can take an example, means like if the analyte is highly acidic or highly basic, then the choice of solvent are very restricted. Means we have to choose a solvent or a buffer which can give you those pH range, means highly acidic or highly basic. So the common organic solvents are not being used in such type of condition, because common organic solvents are like acetonitrile, methanol, then these are the polar. If we will take the non-polar, then benzene, toluene, but this all are having the pH range in between 5 to 8 or max to max 9. But if your compound is having the pH of 11, 12 or 1 or 2, then this solvents cannot be used. So instead of this solvent, we need to prepare buffer. Means like our choice is being restricted now. If the sample matrix is tough, means like your sample is not soluble in one individual solvent. Means like if your analyte is soluble in water, then it will be a very, means like we can say the doors are open for the development, because water is a universal solvent. But if your compound is not soluble in water, then the challenges will start. Then we have to select certain solvent, means like if it is not soluble in water, means like it is non-polar, because water is having the highest polarity. And highest polar solvent, if your analyte is not being soluble, it means it is non-polar. So we have to move to non-polar solvents where we can use the ether, benzene, ethyl acetate, toluene, etc. But our choice again, it will be restricted because the polar doors are closed and we have to move to non-polar only. So this is the challenge. Now the instrumentation. If it is volatile, then we can go for GC, gas chromatography. So the doors are again open for gas chromatography, and the analyte which can be analyzed with the GC can easily analyze with the HPLC method also. But Again, if our analyte are non-volatile, then we cannot use the gas chromatographic method, means the doors of GC are being closed. So now we have to choose the HPLC method anyhow. So our restrictions are being starts. Same way for the pH and temperature. If the temperature range is too higher, means our analyte is being stable at the temperature of 60 or 70 degree, then the choices are limited because we have to choose the solvent accordingly, which can be stable at the temperature range of 60 or 70. So again, the choices are limited. Now comes the fifth point, that is detection of wavelength. Means if we are talking about the HPLC method, it is using UV as well as the visible wavelengths. UV means the range of 200 to 400 nanometer. Visible means 400 to 800 nanometer. So if the detection wavelength is likewise 257 or 323, or suppose 457 or 550, then it is being either in a UV range or invisible range. But if your compound is falls in deep UV range which is 160 to 195. If your compound is fall in deep UV range, then the challenges will start because the common instruments are not working in deep UV range. So we have to purchase an instrument which can provide you a deep UV length, and definitely it will be very expensive. Now comes the last point, that is regulatory requirements. So we have to develop a method which falls in the regulatory requirements, means what your, as yesterday we discussed, that if we want to start our business in US, we have to follow the US FDA rules. If we want to start our business in European countries, then definitely we have to follow the European rules. Likewise for Brazil, for Australia, even though for India. So accordingly we have to submit the documents, means like what are their requirements, that we need to know first, and accordingly we have to file the documents with all supporting data of development as well as the validation. Means like we have to understand their format, and in their format only they can accept the data. So this is the last point that we need to understand. Now comes the second part of today's topic, that is validation. Now suppose we have developed a method which is time saving, which can provide you safety, efficacy, and as well as the quality of the product. So the development part is now over. But the same method should be validated before it can be used in a routine analysis. So the first question should raise like, what is validation part? So validation means what? In one sentence or in common language, as the sir Ajay sir rightly said in the beginning of the lecture, that validation means what? If any method is developed in my lab at Ankleshwar, and if I will get the result of means like 99% in essay by HPLC, then if the same method parameters are being followed by any company in US for the same molecule for the same product, and if the method parameters are being same, then also he or she can get the similar result what I got. Only the variation accepted of 2% relative standard deviation. If 2% relative standard deviation is there, then it can be accepted, but more than 2% are not accepted. Means the developed method should be cross verified whether the results are reproducible, or we have to give certain challenge to each and every develop steps, and we have to cross verify whether our method is strengthened enough that in all labs the results will get similar if the same parameters are being followed, and if the analysts are being different, if the chemicals are being of different makes, if the impurities are used which was provided by the different vendors, but if the molecules are same, so the result should be same. It is known as validated method. Means developed in one lab, but the result should get similar in all labs. If the analysts are not same, if the instrument are not same, if the chemicals are not same, but the parameters are same, so the result should get similar. This is the purpose of validation or the optimization. So in validation, what we are cross verifying? The reliability, consistency, and the reproducibility. We should get the consistent result and the reproducible result if we are performing at Ankleshwar lab or Ahmedabad lab or Amsterdam lab. All three labs should give you the similar result if the parameters are following in a similar way. Whether it is performed at Ankleshwar, whether it is performed at Ahmedabad, whether it is performed at Amsterdam. All three labs should provide you the similar result if the parameters are same. This is known as the validation. If the method is validated, it will give you the result only in the variation of 2%, not more than that. And it is required, the validation, method validation is required nowadays. It is the primary requirement of all the regulatory bodies, means like the US government, as well as the European government, the Indian government, Brazil government, or the rest of the world. They all are asking you about the method validation if you want to start the business in those countries. Also, the Indian FDA is asking about the method validation. If you will give you an analytical method, then the method is not enough if the validation data are not provided. And to validate the method, we should follow the criteria of ICH. ICH, that is International Consortium of Harmonium. Means it is a agency which was developed by the pharmaceutical union, and in pharmaceutical union, the all countries which are having their own regulators, means like US is having their own regulatory, India is having their own regulatory, China is having their own regulatory, Russia is having their own regulatory, likewise Japan. So the member countries are there in a pharma union, international pharma union. They have developed an agency called ICH, and ICH, they have given the multiple quality guidelines, manufacturing guidelines, and all the members countries should follow the guidelines which are prepared as per the ICH. So likewise in method validation, we have to follow the ICH Q2R1 and Q2R2 guidelines, which are made for the validation of any method. Also, the USP 1225 chapter, general chapter number 1225, is related to the validation. The FDA guidelines of India, also the EMA guidelines, that is of European Union. So we have to refer all these guidelines before validate any method. Generally, if you are targeting any country, if you are targeting US as a business country, then you have to follow the US guideline along with the ICH guideline. If you are targeting Europe as your business country, then you have to follow the ICH guideline as well as the European guidelines to validate any method. And if you are targeting the Indian market, then you have to follow the ICH guideline along with the Indian FDA guidelines to validate any method. So likewise, what are the parameters as per ICH guideline to validate any method? These are the listed in present slide: accuracy, precision, specificity, linearity, range, LOD, LOQ, robustness, and ruggedness. These are the parameters are being cross verified during the validation. Accuracy, as we already discussed, that the result should fall in between the asking range. If the range is passing range or the qualification range is 98 to 100, then it should give you the result in between 98 to 100. That is known as accuracy. Precision means what? Percent RSD, percent relative standard deviation of all your repeated analyses 3 times or 6 times are in between the percentage RSD, and the range of percentage RSD is 2. So all 6 repetitions are in between the 2% of RSD. That is known as precision, means your result or your method is validated. Then comes the specificity. Already we have discussed that the main product should identified with all the possible impurities. Means like your method should strengthen enough to identify the main product along with the impurities. Right? Now comes the linearity, the fourth one. Linearity means what? In this step, we are challenging our developed method from 50% to 150%. Means the lower concentration, what we are preparing is 50%, then the 75%, then 100%, then 120%, and the higher one is 150%. And we are injecting this all solutions, means like 50% concentration, then 75%, 100%, 120, and 150%. And all 5 results should give you the percentage RSD not more than 2%. Then it is known as the linear method validation. Then comes the range. Range means the lower concentration of linearity and the higher concentration of your linearity. Means if you have taken the 50% as a lower range of your linearity and the 150% as the highest concentration of your linearity, so we should target the 50 and 150, only 2 solutions, and we have to draw a slope in between the concentration and the results what we are getting. And if it will give you the linear graph, then it is known as that your developed method is working in lower standard as well as the higher standard. So it is the cross verification of your linearity. Means our method should strengthen enough to identify the lower concentration as well as the higher concentration. Then comes the two important parameters of validation, that is known as LOD and LOQ. LOD means the limit of detection and the LOQ means limit of quantification. LOD means what? Detection means like if we are talking about the HPLC method, then from the baseline, the lowest means like which is having the lowest peak of your method also should get detected in such condition. Also it could be quantified. For detection, the limit is like from baseline, your height of the peak should be 3.3 times. Means your baseline is passing through 0, then the height of the peak should be 3.3 millivolt. If it is 3.3 millivolt, then it can be detected, or otherwise it cannot be detected. Means lower than 3.3 cannot be detected. So you have to choose a concentration that your minimum peak should get identified and it should have the height of 3.3 times more than the baseline, 3.3 times more than the baseline. And which peak should get 3.3 times more? The lower one. So we have to target the lower one, means like the lower concentration of your method, and also the lower concentration should have the height 3.3 times more than the baseline. Then the method can be detected. Means like if the lower concentration is detected, then all the higher concentration will definitely detected. So we have to identify only the lower one. Now comes the LOQ. LOQ similarly, but here for quantification we need a more clear idea than the detection. So here the parameters are demanded 10 times more than the baseline. Means the lower one should get the height 10 times more than the baseline, then and then only it can be quantified. For detection 3.3 times more, and for quantification 10 times more than the baseline, then and then only the analyte can be quantified, otherwise it cannot be quantified from the baseline only. Like for detection 3.3 times more than the baseline, for quantification 10 times more than the baseline, then and then only it can be quantified, otherwise it cannot be quantified. Now comes the robustness and the ruggedness. In robustness, it is what we did in the optimization in development stage. Means in robustness, we can change the pH of the analyte, but here the criteria is fixed, 10% decrease and 10% increase. So if the pH of our developed method is 4.5, means like the sample solution what we are preparing, it is having the pH of 4.5. So we can give challenge in validation step by changing the pH 10% in a lower side and 10% in a higher side. Means if the 4.5 pH is there, then we can give a challenge by making the pH 4.05 or otherwise 4.95. So means 10% lower side and 10% higher side. 4.5 is pH, so 10% is 0.45. So 4.5 minus 0.45, that is 4.05. 4.5 plus 0.45, that is 4.95. So we have to analyze two samples, that one is having the pH of 4.05, one is having the pH of 4.95, and analyze the result and compare it with the exact method of 4.5 pH. Means like all three results should get the exact match with each other. So the method is getting validated. Likewise in robustness, we can challenge the pH, we can challenge the flow rate, we can challenge the temperature, as well as we can challenge the polarity of the solvent. But here the criteria are fixed, that 10% in a lower side we can make change and 10% in a higher side. So in 10% lower and higher side, if the results are similar and comparable with each other, then the method is called validated method. Then comes the last one, that is ruggedness. Ruggedness means what? That in this step, intermediate precision is being processed, means like the developed method should be challenged by changing the changing the analyst, changing the make of the instrument, and changing the day. These three challenges are being given in the ruggedness. Means if the first analysis is being performed today, then the second analysis should be performed by tomorrow. If first analysis is being performed by Ronak, then the second analysis should be performed by Rahul. Means like the analysts are changed. And if first analysis is being performed in Perkin-Elmer, then the second analysis should be performed in Shimadzu. Means like we are giving three challenges. We are changing the instrument, but changing the make of the instrument only. the instrument is similar. It's like if we are preparing a method in HPLC, we are taking the HPLC only, but we are just changing the company of the HPLC, the vendor of the HPLC. We are not challenging, no, we are not changing the whole instrument method. HPLC was initially utilized, then the HPLC should be utilized only, but the vendor should be changed or challenged. Analyst should be challenged and the day should be challenged. And if we will get the result in between the 2% of RST, then the method is known as the validated method. So this parameters accuracy, precision, specificity, linearity, range, LOD, LOQ, robustness, and ruggedness. This much validation parameters we should follow as per the ICH guidelines. Now, these are the means like what I have already told you. These are the descriptions only. See here the robustness steps: variation in pH, flow rate, temperature, etc. Now comes what are the validation importance. These are the validation importance. By validate any analytical method, we are ensuring that the quality of product will not get changed if it is performed at any lab by any analyst and by changing the instrument also. We will get the perfect result if the parameters are being strictly followed. Also, the validate method will definitely false the regulatory compliances, the regulatory requirements. Also, the batch failure are being reduces if the method is validated. Validated method means what? That in any condition, if we are strictly following the analytical parameters, we'll get the passing result only. So the batch failure rate due to analytical error are being reduced. Now, due to validated method uses, the confidence of the analyst as well as the analytical result are increased. So one can reliable on the result of the validated method easily. The applications generally validated method are used in pharmaceutical analysis, food and beverage, FMCG, environmental, clinical laboratories, forensic science, etc. These are the many means like few applications, but nowadays the validated methods are required in each and every industry, also in chemical industries. Conclusion that the method development ensures the efficient analysis as well as confirms the reliability and compliances, and both are nowadays essential for the quality assurance as well as the quality of the product. So these are the necessary steps that we need to follow if we want to grow in pharma business or chemical business or in food business. It's like if we want to grow our business, we should follow the development as well as the validation. Okay, with this, I want to conclude my session and I'm opening the question answer session with this.
Thank you, sir. Participants, if anyone has any question, you can ask now.
Am I audible?
Yeah, please.
Yeah, myself, Dr. Anand Maitre.
Yeah.
Sir, like you talked about the analytical methods, development of analytical methods, and validation of the data, but you only talked about the GC and HPLC. But there
Yes,
are
sir.
other methods are also available like NMR, XRD, or
Yes.
other like so. Are they are
Yes.
also the part of this development of method?
Yes. Any method should be developed and validated before it is being used for the commercial analysis. And if it is NMR, MAS, XRD, or any other,
Hmm.
first we have to develop a method and then we should follow this much validation parameters before we are locking the method for commercial uses. So these validation parameters are common for all.
Okay. So as per the requirement, you have to validate the data. You mean to say like Like
Yes,
you are talking about, say, suppose I want to sell my product in US or European countries or elsewhere. So according to
ICH.
their requirement, I have to produce this data also, like
Yes,
analysis part.
this in this slide, in present slide, what you are seeing is the ICH requirements, and ICH requirements are being accepted in all countries, in all
Okay,
member countries.
okay, okay,
If you have validate your method as per the ICH guideline, it is being accepted by all countries.
okay, okay. Thank you, sir. Thank you very much. Informative session, sir. Really enjoyed your session, sir.
Thank you. Thank you.
Yes, any other question from participants? Participants, if you have any query, please ask.
Sir, one more question.
Yes, please.
Sir, like you said that wavelength is, if it is very low, so
Hmm.
then it is problematic. In what sense you want to say that it is a challenging task then?
Mm, see, the common UV, if we are talking about the UV spectrophotometer, then the commercial UV is having will provide you the range of 200 to 400 meters, then 400 to 800 meters. But your analyte, if your analyte falls in the deep UV range, then you need to purchase a deep UV spectrophotometer. So, which will be more costly compared to the commercial UV
Okay.
spectrophotometer. Likewise, if we are talking about the FTIR, then FTIR is having three different ranges. Means like the
Yes.
middle IR range, which is having 650 nanometers to 4000 centimeter
Yes.
inverse. Then far IR and near IR are there. So if our analytes are falls in far IR or near IR, then we need to purchase the far IR instrument or the near IR, which are being costly than the middle IR range instruments.
Okay, so they are not falling in the common instruments which are available in the market. So you have to
Yes.
purchase some
So
of the exactly.
yeah, so we have to purchase a specific instrument, and definitely it will increase your cost.
Yes, yes, right, right.
Generally, method development are being initiated to reduce the cost. But if your analyte is specific, then definitely you have to purchase a specific instrument, which will again increase the cost of the analysis.
Okay, okay. Right, sir. Got it, sir. So as such, if you see, if you go for any kind of analysis, you talk about GCH, PLC, or all costly affairs, sir. Like if you're doing some kind of research, so the main, you can say the cost will be in the analysis part, because unless until you cannot prove your outcome, so it doesn't have any weightage in the, you can say, if you go for presentation of any paper, publication of paper.
Yeah, that's why nowadays the industries are means like they are insisting about the validation. Why? Because due to validations, the failure chances are being reduced. Because each and every HPLC GC analysis are costly. So if
Yes.
you have not validated your method, then the chances of failure are higher.
Mm. Higher
And
rate.
yeah, and due to the higher failure ratio, your cost is being increased.
Yes, yes. True.
That's why they are insisting about the validation.
Okay. Thank you, sir.
Yes, any other question?
Sir, I have one question. Uh,
Yes, please.
Thank you for your very attractive session and very informative session. My
Thank you.
question is that that for the different analytical methods, suppose XRD or NMR or any kind of other different type of analytical techniques,
Okay.
all 9 parameters which we have seen in the screen right now, all these parameters are applicable, or for the different analytical methods different type of out of these 9 different parameters are applicable, 5 or 6, or all these parameters are applicable for the different type of techniques?
That depends upon the method, the instrument, as well as the test is being performed. Means like if I'll take the example of assay and related, means like purity. So in assay, only the accuracy, specificity, and the robustness is being used. Means like we have to validate only the accuracy, then specificity and robustness. Other parameters are not necessary to perform if you are validating the assay method. But in related substance or in purity method, you have to follow each and every step. So it is like depend upon the test as well as depend upon the instrument which is being used. And the guidelines is already given in the ICH that for which method and for which instrument you have to follow out of these 9 parameters, which parameters should follow to validate any method. So we should follow those guidelines only.
Okay, sir. Thank you. Thank you.
Yeah.
Any other question? Anyone has any query, you can ask. So we can conclude today's session here. On the behalf of organizing committee, I extend my sincere gratitude to our esteemed speaker, Dr. Chintan Pandya sir, for delivering an insight and informative session on analytical method development and data validation. Dr. Pandya clearly explained the concept of analytical method development, the guidelines for method validation, and the key validation parameters, emphasizing their importance in achieving accurate, precise, and reliable analytical results in both academic and industrial settings. The session was well structured and highly engaging, and it significantly enriched this FDP. We truly appreciate Dr. Pandya's valuable time, expertise, and efforts in sharing his knowledge with us. Once again, we express our heartfelt thanks to Dr. Chintan Pandya for making this session a great success. Thank you very much, sir. And thanks to all participants to actively participate in the session. Thank you.
Thank you, ma'am. And I am being honored by inviting me in such a nice faculty development program. So definitely, I have enjoyed this session very much, and also thankful to each and every participants. They and the university that they have given me this chance to speak in front of them, and they have actively participated in this session. So I'm thankful to each and everyone. Thank you.
Yes, thank you, sir.
Thank you. Thank you.